Hello everybody, this is Cal with sections 14.1, Functions of Several Variables, and 14.2, Limits and Continuity. So there's a lot of good stuff going on in these sections. I'm going to try to go through them pretty quickly, but I warn you, they're going to take a fairly careful read. We start in section 14.1 by discussing functions of two variables. And there's definition here in the middle of the page, and that's fine. You know, a function of two variables is a rule that takes in an ordered pair of real numbers, x and y, spits out a real number. And your book talks about maybe visualizing this as, you know, you have a two-dimensional set and then arrows going to a line. And that's fine, but that's not the way we will usually visualize a function of two variables. And we'll get to that in a minute. Examples 1 through 4 on the next few pages are meant to familiarize yourself with functions of two variables, and I recommend that you give them, that you pay attention. And there are different functions for different folks here. So do pay attention to examples 1 through 4. Then we get into graphs, which is probably the way we usually will visualize a function of two variables. Remember, you want to think of a function f of two variables as taking in an ordered pair, x and y, sitting on the xy plane, and spitting out a number z above it. And the graph helps you visualize that. I do definitely want you to pay attention to examples 5 and 6 about sketching some simple graphs. You should be able to do example 8 as well. Example 7 requires a computer, so you might not be able to do that offhand, but you know, it still might be worth reading quickly. But you should be able to do things like examples 5, 6, and 8. On 906 here, the book talks about using computers to graph various functions. And, you know, graphs are a powerful tool for visualization. I'm not going to expect you to be able to graph things like this yourself, but maybe recognizing functions from their graphs might be a skill that you should have. Then we get into a discussion of level curves. And level curves are very important for us. They're a really good way to visualize a function when a graph is not handy. What level curves are, and the way I would put it, your book doesn't say this, so pay attention. The way I would put it is that you take a number of z traces and smush them all into the xy plane. And you draw a line in there for every z trace. I definitely want you to understand what's going on with a level curve graph. I want you to understand what figure 11 means, what figure 12 means. And read page 907 pretty carefully. There's a lot of good stuff there. Figure 13 and example 9 is also a really good one. So make sure you're conversant with what's going on in these different examples. Example 10 is definitely something you should be able to do. It follows off of example 5, if I'm not mistaken. And example 11 as well is something you should be able to do. I really like example 12. Pay attention to it especially. I really like figure 17b, where it kind of shows how it's getting from z traces to the level curves down below. You don't have to pay as close attention to example 13, but it's not a bad example. Now, at the bottom of page 910, we get into a discussion of functions of 3 or more variables, and they work like functions of 2 variables. If you have a function of 3 variables, instead of taking in a point x, y, and spitting out a number, it takes in a ordered triple, x, y, z, and spits out a new number. Functions of 3 or more variables are a little interesting because they're a little harder to visualize than functions of 2 variables. Your book gets into some discussion of this on page 911. Example 14 is just an example to familiarize yourself with functions of 3 variables. Example 15 does get into visualization, and that's a good one to read. I like figure 20 here. I will say on top of that, and we'll go into this in class, that level surfaces are a useful tool for visualization. I also really like, if you have a function of 3 variables, you can think of it, remember this is spitting out a number at each point in 3 space, so you can think of it as something like, a temperature at each point in the room, or a color at each point in the room. And that can kind of help you visualize what functions of three variables might look like. I really like this discussion at the bottom of page 911, talking about different ways to look at a function of many variables. And these three ways are all interchangeable and sometimes useful. And then we get into the exercises, and the only thing I'll say is I really, really like problem 32, matching the functions with the graphs. And I really, really like problems 39 through 42. That's definitely something you should be able to do. And I really, really like problems 59 through 64, matching the functions with their graphs and their level curves. These are all excellent problems to help you focus on visualization. Anyway, moving on, let's go to section 14.2, limits and continuity. Now, this is a really hard section. This might be actually one of the hardest sections that we do all term. And I want you to pay attention to the motivating example in the beginning of the section with this f of xy, this g of xy at the bottom of page 916. And I really like where they've made little charts of values for f and for g. And I want you to look at the differences in behavior between these charts and kind of think about why this might mean that the limit as x and y approach 0, 0 of f exists, and why that limit for g does not. If you understand these two examples, then you're going to understand a lot of what we're saying in this section. Now, the book gives a precise definition of the limit involving epsilons and deltas. We're not going to worry about that in this class, but you'll notice if you do read it that it has similarities with the definition of a limit, like in Calc 1 for functions of one variable. I'm not going to say this isn't important, but we're not going to be asking anything directly on it in this class. I really do like the discussion starting at the second paragraph of 918, starting with the sentence for functions of a single variable when we let x approach a, etc., etc. Read these next few bits carefully. These really give a good idea of what we need to worry about with limits of multiple variables. And it's summed up in this box right here. This is going to be really, really important to us for the next three examples. And I want you to pay really, really close attention to examples 1, 2, and 3. Read them carefully, make sure you understand exactly what's going on in those three examples. They're pretty huge. And they're one of the main things that I can ask you about in this section. Because if there's a takeaway from this section, it's that proving that a limit does exist for a function of multiple variables is really hard. But proving that it doesn't exist is something that's definitely within our powers. So pay really close attention to examples 1, 2, and 3. Now, starting at the top of 920, your book talks about limits that do exist and has some limit theorems about them. And you might want to refer back to section for if you have the Calc 1 and 2 book, this would be section 2.3, if I'm not mistaken. In this ebook, it's section 1.6. Example 4, don't pay too much attention to. Like I said, we're not going to be doing epsilon delta arguments in this class. Do read the section on continuity. Continuity defined in functions of multiple variables is the same definition as it was for functions of one variable. And so, you can handle questions like example 5, certainly. Example 6 and example 7, sure. Example 8, I suppose, if you take example 4 as given. You can certainly do example 9. That's within your power. Do read lightly the discussion of functions of 3 or more variables, but if you understand the case in 2 variables, 3 variables is not much of a stretch. We will talk in class about how to actually show limits exist, but the takeaway here is that it is difficult. So that's all I have for these 2 sections, and I'll talk to you guys later.